Okay, morning, folks. The time around, I'm doing a series of recordings on all the questions that were written 2025 to do with forces and vectors. I hope you find this interesting. And if so, please remember to subscribe to the channel, hit the like button so that you can always receive notifications when new recordings are done. Thank you. All right, let's move in. Let's see. Am I able to raise this? Let's see. Okay, it looks like I am now this time around. Let me try and pick the first person. What are we seeing here? We're seeing an object experiencing three forces, and we have got two unknowns, x and theta. And normally when this happens, people you can quickly think of the trigonometric identity, tan theta being equal to sine theta over cos theta. Why is this important? Because we know in our horizontal axis, we normally deal with the cosine function and the vertical, that's the sine. So let's see if this will work for us. Three coplanar forces of magnitudes are 40, 30, and x are pointing directions shown in the diagram. Given that the forces are in equilibrium, find the values of theta and x. So what I'll do here, I'll try and say, okay, the components of the x, they are going to be in this manner. I have an arrow there going down, I have an arrow. So this is going to be x cos theta, and this is going to be x sine theta going to trigonometric. So now, what do we do with those? We are saying along the x-axis, we have only two forces which are acting opposite directions. We are told they are in equilibrium. So I'm going to say in the x direction, I'll put an equal sign somewhere in the middle part. Then I'll say x cos theta. This should be equal to 40 newtons because we don't have anything in the y. Then when I move to the y, this is what we have. Then in the y, let me release a bit. We've got 30 newtons. So I'm going to say 30 equal to, because it's equilibrium, that's x sine theta. Now, rearranging, because I had the identity sign over cos, if I rewrite this x equation below, what I have is 40 equal to cos theta. And when I did divisions correspondingly, so the x's are going to go away, then I'll be left with one variable which is unknown, that's theta. So simple, because we take this simplify to tan. So in making this up into formula that tan theta is actually equal to, see these zeros will cancel. So that's 3 over 4. But I'm interested in the value of theta. Then I'll raise my calculator to say, second function, I need tan. That's arctan of, here's a fraction. I'll put 3, then denominator 4, I go up, close my bracket, and I say equal, gives me 36.869. Well, I can round it to perhaps one decimal place that will give me 36.7. So I can come to say my theta is 36.7 degrees. So once I have theta, it means I can use any of the given equations to find the corresponding value of x. For instance, if I use this one here, I'm going to say somewhere here 40 is equal to x cos, instead of theta, because theta is known as 36.7. So the 36.7 degrees. So now if I divide both sides by cos 36.7 degrees, that will give me the actual value of x. So like that. So here numerator and denominator the same. So end up having x equal to. So when I bring my calculator, I'm going to divide 40 by cos 36.7. And this will result in 49.88. And if I'm to round it to one decimal place, it's more like 49.9, approximately 50. So my x is 49.9 newtons. I think you found it interesting. That was the first part of questions to do with positive vectors, which were done in year 2025. Thank you.